Okay, Assalamualaikum and good afternoon to our lecturer, Dr. Ahmad Fuad bin Abdul Rashid. My name is Muhammad Afizuddin bin Samsudin, and today we will present the solid mechanic assignment, force and factor of safety analysis from actual structure. Okay, for the introduction, every component in a linear motion system experiences some form of loading due to apply force or motion. The component reaction to this load are described by its mechanical properties. For components subjected to tension of compression such as load carrying ball and roller, shaft mounted vertically or fastening and joining hardware, the mechanical properties of stress and strain play an important role in determining whether the component can withstand the application loading condition. Stress is the force applied to the material divided by the material crossing-sectional area. For this was the uh, formula for stress, force, and original cross-section area. Okay, the strain is the deformation or displacement of material that result from an applied stress. The symbol for strain length after load if applied. This is original length. For our objective is to draw the detailed FBD from actual structure related problem. FBD is um, full body diagram to develop equilibrium question from the from body diagram draw to analyze force member from the structure to determine the factor of safety in the structure. Okay, for our assignment, we decided to choose the badminton net. This is the detail for our structure. Um, this is a free body diagram for the badminton net. We assume pole A and pole B have a diameter of 100 millimeter. Yield strength of the polyylene nylon pole is 1,100 megapascal. The mass of the net is 3 kg, 3 kilogram. So for calculation, this is calculation for EOE. For the EOE, Fx equal to 0, Fy equal to 0. So Fa plus Fb minus the values equal to 0. Sin Fa, Fb are equal. So their force will be same. That we get 14.7 Newton. Okay, that is for me. I will pass to my partner Adam Ilham.
Okay, thank you, Hafiz. So I will continuing the calculation for the moment and shear. So for the moment and shear, we decided to divide the net to 4 square. So for this page, which is two first square. So this is the first square. Have a momentum 2.42 Newton meter. So the second square, for the second square momentum is 44.84 Newton meter. So the second page of moment and shear, the third square have a momentum which is 22.37 Newton meter. And lastly, for the whole momentum of the fourth square is which is 0 Newton meter. So they have 0 Newton meter. Alright. And then for the calculation of stress and shear stress, so the first one is stress. Stress has a formula which is force divided by area. So the stress for A is 1871.66 Pascal. So the stress B is the same, which is 1871.66 Pascal. And then for the shear stress, we have the formula shear stress, which is V divided by A. And then shear stress for A and B is the same, which is 1871.66 Newton meter square. And then the calculation for factor of safety is stress fail divided by stress allow. So since the Fs is greater than I, the potential of the member to failure is low. So the total for factor of safety is 587713.580.
So, in this page we have discussion, and the first discussion is the factor of safety is a measure how much stronger a component or structure is compared to the maximum load it is expected to encounter. It is calculated by dividing the ultimate strength or yield strength of the material by the applied load or stress. The factor of safety provides a margin or safety to account for uncertainties in material properties, loading conditions, and other factors that can affect the structural integrity. It is important to note that the specific design and safety consideration may vary depending on the application and industrial standards. So the design codes and guideline provides recommendation on factor of safety values based on the material properties, expected loads, and other relevant factors to ensure safety and reliable structures or component. So next, we have the conclusion. The first conclusion can be that we can apply our knowledge on how to determine the torque, torsion, and the maximum shear stress. Next, we have the next conclusion is we can develop our knowledge on mechanical behavior or properties of a material. Then we the capability to function efficiently as individual, as members, or leader to work in group. Lastly, the conclusion is since the factor of safety greater than 1, so the potential of member failure is low. So that's all from our group.